Hi, I'm Rick Leuttich, faculty member in marine sciences at UNC Chapel Hill, and I'm pleased to have a few minutes to give you a brief summary of the study we've done on water circulation in Falls Lake, North Carolina. This is work I've collaborated with fellow faculty member in marine sciences, Harvey Seim, and has been capably carried out by Tony Whipple and Ollie Gilchrest. Our principal research question is to document and understand the circulation patterns in Falls Lake. At very long time scales, we know that what comes in, which is largely at the upper end of the lake, must eventually go out at the lower end of the lake past the dam. There's also been a few short-term, hour-long studies of velocity in the lake, but there's really been very little that's done to link how the inflows and outflows, how, say, the physical properties in the lake, how seasonality influences the circulation structure that occurs. And of course, we're quite interested also in the implication of this circulation on water quality. For instrumentation, we deployed two systems. One were moorings from the surface to the bottom that contained every half meter temperature sensors, and also at some locations light sensors. And then a second system, which was an acoustic velocity meter, which sat on the bottom, shot an acoustic beam up through the water column and measured the water velocity, its speed and direction in half-meter increments through the depth. We recorded data with that every 10 minutes and the moorings every 6 minutes. And we did this over a 16-month period from November 2019 until February 2021. As a brief reminder, Falls Lake is an impounded riverine system, and you can see clearly in the upper half or so of it, on the left side of the figure, the water depths are much shallower, as indicated by the light blues. You can see the channel in the dark blues, but the periphery is shallow. There are shoals, and the water can spread out much more broadly. Whereas in the lower part of the lake, it's deeper, it's narrower, and much more confined to the historic river channel. We deployed our instrument systems at 4 different locations in the lake. Near the upstream end where I-85 crosses, we deployed a current meter only. And then where Fish Dam Cheek Road, Highway 50, and Highway 98 cross, we deployed both a mooring and a current meter. We were also able to get data from the dam at the far low end, where we could get water elevations and discharge. And then around the periphery of the lake, we could get data on river inflows and stream inflows from USGS sources. So I'll give a brief overview of some of the observations that we collected. This is for the month of February 2020. If you look at the lowest plot and the red line, you'll see a big blip around the 7th of February. That's a very large discharge event that came in from the rivers upstream of I-85 and then propagated down through the system. The green line that's close to it in the lower plot is the discharge we measured, and this is at Fish Dam Road. And so this is showing a similar discharge, but slightly lagged in time. Another thing that you see slightly later in the month, on or around perhaps the 11th and then the 14th, are a couple of smaller input events, the red bumps in that lower plot. And then you also see the blue line in the lower plot. It's almost zero near the first half of the month. And that's the discharge past the dam. So little water is going past the dam. But about the 12th of the month, you can see that it ramps up. And then throughout most of the remainder of the month, it's at a higher level above 100 cubic meters per second. And that's essentially water being let back out of the reservoir. If you look at the second panel from the top, you can see concurrent in time with the big river input, a big solid dark color which is the velocity measurements that we measured at Fish Dam Road. And what you see is a big pulse of water being pushed downstream. The velocities there reached about 75 centimeters a second for a couple of days. Interestingly, both before and after, the velocities were much less. You see a lot of greenish colors, and the greenish is actually right about zero velocity, so very little transport through the lake is occurring right prior to that big event and right following that big event. Then around the 12th or so of February, you see two red stripes, which correspond to the lesser river input events that occurred. And then you can see after that, it's yellow for most of the rest of the month. And what that yellow is water velocities. Yellow to orange is water velocity of about 10 centimeters a second going past Fish Dam Road. And that reflects not so much the input pulses, which are in the brighter red stripes, but rather just the sustained drawdown in the lake due to the discharge past the dam. The other thing to note is the temperature record, and you can see that it's quite well mixed over the depth. So the blues are very constant over the depth, and they range in the neighborhood of 7 to 13 degrees Celsius. Toward the lower end of the lake, we see a similar signature. Again, at the bottom, reminder of the red line is the big riverine input. Move up to the second plot, which is the color plot, and you can see that signature occurring even at Highway 98, although it's more muted than near the upstream end of the lake. It is preceded and followed by very still water, and then starting on or around the 12th or so of February and through most of the rest of the month, a steady downstream flow, which reflects, again, the drainage out of the lake that is occurring at the dam. I'll point out that the black line that is just above that indicates that the water level went up by about 2 meters during the course of that big rainfall event early in the month, and then gradually was drawn back down via the discharge at the dam throughout the rest of the month. I'd like to contrast this now with the same data from August of 2020. The first thing to notice along the lower plot is no red blip, no major riverine inflows into the system during this time period. And rather, all you see are sort of a wiggly line, oscillations, if you will, in the discharge that we measured at Fish Dam Road. You can also see that in the stripes, in the green, yellow, blue stripes in the second plot from the top. Really, what you're seeing during this time period is very little flow through the lake, and the velocity is just oscillating back and forth, sloshing back and forth in the along lake direction. The other thing you can clearly see is the change in temperature. We're now up in the 20s and 30s degrees centigrade, bathwater, and substantial stratification or much warmer water on the surface than on the bottom. During this same time period at Highway 98, again, we just see a lot of oscillations occurring there in the discharge, and you can see it in the stripes in the velocity plots, the second plot down. A lot of kind of back and forth oscillations. But if you look closely, you can also see that throughout a lot of the time period, the colors near the top are in the yellows, which indicates a downstream flow, and the colors closer to the bottom are in the aqua or blues, and that indicates an upstream flow. And so we're actually seeing oftentimes a two-layer flow develop during this time period, much of the time being downstream towards the dam at the surface and a bit upstream close to the bottom. The third plot down indicates very strong stratification, up to 14 degrees Celsius from top to bottom, and again, very warm waters near the surface. Using data collected by the Upper Neuse River Basin Foundation on the bathymetry and surrounding topography of the lake, we've been able to also construct residence time estimates for the flow through the lake. The blue line on this curve represents the residence time at full pool. It is also a function of whether the water level is above or below full pool, which is the other curves. But this indicates that depending on the discharge, which is on the x-axis, the residence time can vary from tens of days to even hundreds of days, which is along the y-axis. I'll note that about 2/3 of the time the lake is within plus or minus half a meter of full pool, so that blue line is probably a pretty good representative curve of residence time. If we then take the 41 years of discharge data from the operation of the reservoir, this is the discharge data at the dam, and superimpose it, we can look and get a sense if we pick out the 50% time on that discharge curve, we can measure over. So that means that about half the time the discharge is less than, say, about 5 cubic meters per second. If we measure down to where that hits the full pool residence curve, and then over to the x-axis, what we come up with is a average residence time or a median residence time in the system of about 330 days, or a little bit less than a year. So to summarize, I think we've developed a much more complete picture of the circulation in Falls Lake now. Certainly we've documented the strong along lake flow and the way in which it responds to inflows and dam operations on scales of days to weeks. We've identified a 5.5-hour oscillation that occurs quite frequently in the lake. And while it may be small compared to the along lake flows, when the along lake flows are very small themselves due to minimal inflows or minimal discharge, they can become dominant in the velocities, as can become two-layer flow when the lake stratifies in the summer months. And we've identified at least a median resonance time of probably something a little bit less than a year in the lake. We have a number of additional analysis and synthesis that we're still working on, and look forward to a more full presentation of the results in the near future. And we also look forward to interacting with colleagues and others to fully flesh out the water quality implications of our findings. Thank you.